Hello. So today I don't have any slides for you. My booth is right over there, and it's a demonstration of 3D terrain visualization using stereo 3D. So you have to have special glasses on for it to look nice. So I couldn't do it justice on a normal monitor. So if you'd like to see the maps, I'm right over there. I'm happy to show them to you. So a bit of the backstory of this. The software was originally developed at the Army Research Lab. One of the very first purposes for it was as a Buckeye Viewer. So Buckeye is an Army program to collect LiDAR and photos from the same aircraft. And then to visualize that, as I show over there, the 3D terrain is created using the LiDAR, and then we apply the imagery as a texture on top of that. So one of the innovations, one of the special aspects of our viewer relative to others is the stereo aspect. So we believe that the stereo gives you a better understanding of the local slope of the terrain. So as a soldier trying to understand the terrain and trying to plan a mission, it's important to know how steep the cliff is on each side of you. So the tool has many features that have been added over the years for mensuration. You can lay out a route from point A to point B. It will then measure the route for you in total distance and change in elevation. There's a line of sight tool to where if you click on a peak, it will shade where you'd be seen from that peak. And while I don't feel like I can tell a soldier what route to take, the tool allows you to make measurements. So the soldier can have a quantitative can make a decision using quantitative measures for their given situation. So in the demo that I show, I lay out 3 separate routes. One is through a valley. It would be the easiest route, but it comes very close to an enemy position. There are 2 more routes that run through the mountains, and those would be much more difficult paths to take because of the elevation they'd have to incur, but they are. One is farther away from the enemy position. The other one is on the opposite side of the mountain peak. And you can, with the stereo 3D, you can see that you're traveling up the backside of the mountain. One of the benefits of the software is we keep all the data at full resolution. So Buckeye Data typically is, the LiDAR is 1 meter resolution, and the photos are at about 10 centimeter pixels. So if you were to downsample the photos to the resolution of the LiDAR, you would lose a lot of information in the imagery. And the paths that we select through the mountains are footpaths through the mountains, so they're very narrow. You wouldn't be able to drive on them. And if you were to downsample to 1 meter resolution, you wouldn't know they were there. So a mission planning tool where you can't see those paths through the mountains would not be of much value. So the viewer can visualize multiple types of data sets, including Buckeye and several other LiDAR data sets, but it also can visualize point cloud data sets generated from photogrammetry. So today you've seen several other presenters talk about the benefit of giving the soldier the ability to collect their own data and build their own maps. So you can go out and fly a UAV, collect imagery, and using photogrammetry software, build 3D maps. We work with researchers at the University of Southern California. Institute for Creative Technologies is one of our partners, and they have a program where they fly a drone over terrain, collecting imagery and building maps from that, and giving those as a kit to a soldier so they can take on missions with them and collect their own data. And others have shown the value of that today. The third demo that I show over in my booth is the newest functionality we've added in is the integration of real-time sensor data into the map. So last summer in an exercise, we went out to the desert at Fort Huachuca, and the guys at ARL who developed sensors brought the sensors and placed them in the field. And as those sensors come online, they report their GPS position. So we were able to intercept those sensor reports and in real time place the sensors in the map. And then as the sensors start collecting data, the information shows up on the map. So You can see sensors. You can see a acoustic sensor showing a detection in a certain line of bearing. You can see seismic sensors showing proximity detections. There's motion around those sensors, and there's imagers that are collecting images based on when there's motion around those imagers. And then you can click on those sensors, including the imagers, and get information about what's being collected. So the imagers, you're seeing the images that cause the sensors to be triggered. And we see the workflow of giving the soldiers the ability to collect their own data on one hand, taking those maps from that data and viewing them in a 3D viewer so that they can then work out where to best place their sensors in the map so that those sensors have the field of view and are able to collect the data that they need to surveil a large area. And then as those sensors are turned on, they show up in the map and you have a surveillance tool. So an end-to-end process where you enter an area, the soldiers can collect their own map data and build their own surveillance terminal where one person can sit in front of the console and make sense out of potentially hundreds of sensors that otherwise, without a map, would just appear like noise. You wouldn't, when 30 sensors go off, without knowing where they occur in the map, it's hard to detect patterns. So in the viewer, when I was out in Fort Huachuca this past summer, I was able to tell the people in the trailer where I was when the guys were entering the field, because I was seeing the sensors being triggered prior to them reporting on the radio that they were starting the next test. So it gives you a good way to observe a lot of sensors that you otherwise wouldn't be able to make sense out of. So that's what I've prepared. I'm happy to answer any questions you might have. Yes. So the question is, do they use any of that stuff today? The viewer itself is available on the Army Geospatial Center website. It was initially, one of its first purposes was a Buckeye Viewer. So the Army Geospatial Center distributes Buckeye Data. So if you go with a CAT card, you can go download Buckeye Data and you can download the viewer. Beyond that, I don't know of any instances where soldiers are using it in the field, although we are actively trying to get it in the hands of soldiers so they can get some benefit from this tool.
So today there's still a 1 meter max resolution as a soldier tries to track the active mountains.
The newest Buckeye data that I've seen is actually 0.5 meter spatial resolution and 5 centimeter pixels. And I know there's a new Buckeye program where they're trying to, the aim is to collect data at least at that resolution, but at higher elevation. So that is constantly being improved upon. But the data that the soldier had, I believe that's pretty much the state of the art as far as soldier elevation information that goes as well. But the nice thing about photogrammetry would be you can fly at a much lower elevation, you get a much smaller footprint map, but you can potentially get very high spatial resolution of the terrain. So if a soldier really cared about one small area, they could send a disposable UAV out and collect an hour worth of data and build as nice a map as they want. It just depends on how much time they want to spend collecting data. Okay.